and hello everyone. Let us continue learning C language. In this video, we are going to discuss about yet another form of derived data types, and those are structures and unions. Now, structures and unions are very commonly discussed topic in C language, but there are few details in structures and unions which is yet to be disclosed. Let us discuss about structures and unions in this video. Let's get started. Now, the first primary difference between arrays and structures are nothing but arrays are collection of similar data type, whereas structures and unions are collection of different data types. So you collect different data types of different primitive types, whatever we have in C language, that is either integer, character, float, or double. You collect it and put it under one package or one structure and use variables for that structure, and those are called as derived data types. And let us start writing a code for the same. So we are beginning with our header file here, which is hash include standard input output.h, and we are having our main function here. We are starting with our main function, that is int main. Now, before in hand, I'm creating a structure called student, and in that I'm having a character variable C, an integer variable A, and a double variable D. I'm ending this with a semicolon for the structure definition. And I also have a union in place to talk about the differences of the same. Or before in hand, let's talk structures in details now. Here, in the way we are going to create an object for the structure student here is nothing but I have to use the word called struct, stud, and yes. So yes is a variable of type struct student. And in that, s.c is a character variable. I'm storing a in it. s.a is an integer variable in which I'm storing a number of 34. s.d is a double value with which I can store a value of 4.567 are random numbers I'm providing it. And ending with the return 0 statement. So I'm not printing anything here. This is a very simple code for you to understand how the variables or the values can be accessed. So I'm compiling the whole program here with word of gcc args.c -o args. So the compilation is successful. So when I run it, I don't see any output here. Reason because I'm not printing anything on the screen. But this compilation is to show you the compilation is successful here. So this is the way of using it. Now the same thing, same structure can be replaced with the keyword of union here, and both of these works the same way. Now the first and the primary differences you have to know in terms of structures and unions are nothing but the memory allocation, the size allocation process. Now if this was a structure, as we had it in the earlier case, if this was a structure, inside the structure we have got three different variables, C, A, and D. The size of C, which is basically a character variable, which is 1 byte. Which is 1 byte. The size of integer variable is 4 byte. For a GCC compiler, again that is dependent. And for double variable, it is 8 bytes. So the total memory for this struct student is nothing but 8 plus 4 plus 1, you'll have 13 bytes in place. You will have 13 bytes in place. If this was a union, then the highest among these three values is 1, 4, and 8. The highest among this value variable is 8. So only 8 bytes will be allocated. The highest among it will be allocated. The remaining will be left as it is. So the memory, whenever we use all variables, you cannot use all the variables at the same time. And if it is a union, you have to use only one at a time. But if it is a structure, you can use all the variables in the structure at the same time, as because we have enough memory for all the variables inside the structure. And this is in short about what you mean by structure and what you mean by union. And when you read about or when you learn about structures and unions, you should also know something called as type definition. Now, type definition is a keyword which is used to define types. Now, whenever you create a variable for this structure, you have to call it as struct keyword and the stud, that is the structure name, followed by the variable name. That is how we have to create variables for each and every structure or union, whatever it is. You have to follow by the keyword and then the structure or the union name, followed by the variable name. Now, since this writing is a very lengthy process, this type define helps you to shorten the writing. The way I can define this nothing but I can say struct student. This is basically a type. This is the type name what we have right now. And this type name can be shortened as stud. So stud is a shortened name. And these two names need not be same. I can have different names also. I can even have stu and a short name in place. Which means wherever I need to write struct stud can be replaced with the short name which we have right now, which is stu. I'll compile it one more time to show you that there are no errors. And this is an allowed way of writing in terms of C language, that is using a shorter form type definition. So type def stands for type definition. We are defining a new type structure student with a short alias name. So that is the purpose of structures, the type definitions here. Now, apart from it, we also had a debate or discussion in terms of memory sizes. Now, as you could see on the screen right now, we do have three variables inside the structure, and those are character, integer, and double variable. So the size of this we are expecting it as 13 bytes. But in our main function, let us go back and execute the size of it. Let us print the size of it using the function of printf %d, comma, size of int. So the size of stu. Okay, when I compile it, clear the screen. Semicolon was missing. I'll put a semicolon in place. I'll compile it. When I run this, you can see the output is not 13, it is 16. So I'll do a small correction. I'll delete the int line from here, and I'll put the delete int line after the double statement. Now I'll compile one more time. I'll run it. Now you could see the size is 24. Now, however you shuffle it, the size will always be a multiple of 8. The reason because I am right now using a 64-bit compiler, 64-bit version of it. My system is a 64-bit architecture. So whatever the value we get is always will be a multiple of 8. But apart from it, why the size is not 13? We have got the size as 16 and 24 correspondingly, but still, even when it was 16, we had the same three variables. Even when it is 24, we had the same three variables. Now, what happens in place is nothing but the blocks are in sizes of 8 bytes as a sequence. So the blocks inside the memory are blocks of 8 bytes. So what happens is the variables are stored in order. So inside the structure, the first variable you have is a character variable. So when you allocate 1 byte for a character variable, that is in a block of 8 bytes, as I said, when you allocate 1 byte for a character, you cannot use the next 7 bytes because the next type you have is a double. In Q, the next variable you have is a double value. So what the compiler would do is, since the first byte is given for the character, it leave all the next 7 bytes empty, it leave those 7 bytes unused, and it will take the next complete byte set of 8 bytes, and that complete 8 bytes will be given to the double variable. And the next variable type you have is an integer, so I want 4 bytes. So this 7 won't be reused. Rather, after the second byte of 8 bytes, I have the next block, and the next block will be made use. And in that block, I'll allocate 4 bytes for the integer a variable. Right? So since we have made use of 3 blocks here, the size has become 24. But instead, when I delete this line and paste it here, and I use the integer variable as my second variable, so what it does is the first byte will be given for a character, and I have next 7 empty spaces. Out of 7, 4 will be given for the integer block, and I've got only 3 remaining. So next variable type is I have a double, and that for double I need 8 bytes. So this 3 won't be used. I'll take the new set of 8 more bytes, and that will be completely given to the double variable. So here I have made use of only 2 memory blocks here, and that is why the size is being set to 16 here. So that is in short about how the memories are allocated for structures in C language. And we also discussed about what type definitions are. And we also have discussed about what unions and their sizes could vary and how it is being manipulated and used. Hope this video was clear to you guys. See you in the next video. Thank you.